Hello. This video is going to show you about the organization of the sympathetic trunk or chain. I'm going to start by drawing the H-shape gray matter. If you haven't already, please make sure that you've watched the video on the cross section of the spinal cord, because this will really build on that video. So that's our gray matter. I'm going to draw the white matter. Okay, all of this will happen bilaterally, but I'm only going to draw it on this side. So you will remember that we have our dorsal root with our dorsal root ganglion that is going to unite with the ventral root to form the relatively short spinal nerve. Now that spinal nerve is going to divide into a small dorsal primary ramus and a larger ventral primary ramus. Now what we haven't shown you this far is that at certain levels, this gray matter actually has an extra horn. So I'm going to add this in now. In the thoracic and upper lumbar, so from T1 to L2, you're actually going to have this lateral horn. Okay? And then what we'll show you is that our motor neurons, these are sympathetic neurons. Sympathetic neurons are now going to originate from the lateral horn between the level of T1 and L2. They will travel along the ventral root. They are motor. They will travel along the spinal nerve and into the anterior primary ramus, or the ventral primary ramus. Now from here, these axons are going to exit along a structure that we're going to call the white ramus communicans. So we're going to give it a little bit of structure here. That's going to continue on for regular motor neurons. Okay. So this becomes fairly complicated, but this is going to be what we call a paravertebral ganglion. Para, because it's running parallel to or beside on either side of the vertebrae. So we have this single sympathetic neuron traveling along spinal nerve, ventral primary ramus, along the white ramus communicans, towards this paravertebral ganglion. And it has a number of different things that it can do. So I'm going to show you, by splitting this, all the different things it can do. It can synapse right here with something else. Okay. It can run downwards towards a lower level of the vertebral column. It can turn and run upwards towards a higher level of the vertebral column, or it can pass right through and continue on over here where it will land at another ganglion. This would be called the prevertebral ganglion because it's in front of the vertebrae. Let's talk about that example first. When that happens, this segment here is referred to as a splanchnic nerve. All of this so far is myelinated axon, which is why this segment here is referred to as the white ramus communican. It's got white matter or myelin surrounding it. When you have the synapse here, the next vertebrae is going to be unmyelinated. And it also has options, but one option is that it could pass back into the spinal cord to head out to another level, and this would then be called the gray ramus communicans. So when we're talking about the sympathetic nervous system, even though this feels like a long distance for a neuron to travel, if you think about the space it takes up in the body, it's actually relatively short. And then the post-ganglionic neuron is going to be long because it's going to travel all the way to the target organ. There are 30 times more post-ganglionic neurons in this system than there are pre-synaptic. And when you stack all of these ganglia up together along either side of the vertebral column, this is why we call this the sympathetic chain or sympathetic trunk.